I welcome you all to this lecture on average areal rainfall. It is also commonly called as mean areal precipitation. This is a fundamental concept in hydrology, especially when we are working with catchment areas, river basins, or watersheds for things like flood estimation, water resource planning, or hydrological modeling. In catchment, there are various rain gauges assessor installs. All the rain gauge may not give same rainfall quantity during the same storm event. As shown in this figure, each rain gauge in a single catchment gives different uh, precipitation. So, if we need to give a representative data of a catchment for rainfall for a catchment, then we need to estimate the average aerial rainfall for that catchment. There are various methods to estimate average aerial rainfall. In this lecture, we will understand the four methods, namely arithmetic average method, seasonal polygon method, isohetal method, and reciprocal distance squared method to estimate the average aerial rainfall or precipitation. The arithmetic average method is the simplest way to find average aerial rainfall. Just add up the rainfall from all gauges and divide by the number of gauges. Here, in this formula, it can be understood. Suppose there are n number of rain gauge in a catchment, then we may find the average aerial precipitation P average as P1 plus P2 plus 2 Pn divided by the number of rain gauge station N. So it can be also written as or expressed as 1 by N summation Pi, where I is 1 to N. Now Pi is the rainfall recorded at ith rain gauge in the catchment and N is the number of rain gauges. These methods work best when the catchment is physically and climatically homogeneous. Terrain is flat and the catchment is small. And the gauges are evenly spaced and uniformly distributed. The another method to find the average aerial rainfall is Thiessen polygon method. To understand this method or to find the formulas, to learn the formula for this method, first understand there are some assumptions. Thiessen polygon method, also known as the Thiessen or Voronoi method. The assumptions of this method are any point in a catchment gets the exact same rainfall as its nearest rain gauges. Suppose this is a catchment, and here is the station. There are stations. Suppose this one, this three station A, B, and C are the gauge or rain gauge station in this catchment. Now we need to uh, if we ask to say the rainfall at this point, then we can say the rainfall at this point is the same as rainfall at station A. Why? Because the rain gauge A is the nearest to this point, and the influence of each gauge extends halfway to the near neighboring gauges in every direction. So, suppose this distance between A and B is this one. So the influence area of each rain gauge extension is the exactly halfway of the distance between two nearest rain gauge extensions. In this practice, the whole catchment is divided into several polygons, and each polygons belongs to one rain gauge. So here, suppose this is a catchment as shown in this figure, and the area of the catchment is A. And this catchment has three rain gauges station P1, P2, P3. The very first step of this method is to join each station by a straight line to form a triangle. As here now, each line is bisected perpendicular, or draw the perpendicular bisector of each side and extend this bisector to the boundary of the catchment. Here also, extend this bisector to the boundary of the catchment. Now, join this line. Suppose this is the joining. So now, here we can see there are three areas formed: area 1, area 2, and area 3. Now, and this area is named as Hessian polygons. Now, the next step is to define the area of each polygon, and then compute the average precipitation by this formula. P average is equal to 1 by A. A is the area of the catchment, then summation AI Pi, where I starts from 1 to n. And AI is the area represented by the ith polygon. As stated here, the area AI, suppose this is A1, A2, and A3. So A1 represents the area of this first polygon. A2 represents the area of second polygon. And similarly, A3 area represents for third polygon. And Pi is the rainfall recorded at this rain gauge. So P1 is the uh, average or precipitation for this polygon 1, and P2 is for 2, area 2, and P3 is for the polygon 3. Now, by this formula, we can find the average aerial precipitation. There are some disadvantage of this method. Whenever we add, remove, or move a hinges, then we have to redraw all the polygons. Even if just one gauge stops working, suppose one rain gauge stopped working due to some malfunctions, then the whole process repeats with a new set of polygons. Hidden polygon method does not handle orographic influence or orograph effects well. In hilly or mountainous area, rainfall changes a lot due to elevation. Lot due to elevation. This method ignores topography completely. They treat the area as flat and assume rainfall depends only on distance to the nearest gauge. Because of this method, this method works best in a flat plains or flat areas, but less reliable in complex terrain. For better results in varied topography or complex terrain, we turn to the next method, which is called the isohedral method. To understand this method, first just understand the terms isohed. Isohed is a line joining points of equal rainfall. The same as the contour line. So an isohed is a contour line joining points of equal rainfall. This contour show how rainfall gradually changes across the catchment. So here in this figure, the contours line or isohed is depicted. This lines means at each point on this line, the precipitation is same as 4 centimeter. Similarly, at this line, at each point on this line, the precipitation is same as 5 centimeter. And the third line, at each point on this line, the precipitation is 6 centimeter. So for this method, first we need to calculate the average rainfall depth of two boundary isoheds. Suppose this isohed 4 centimeter and 5 centimeters, so we need to calculate the average rainfall for these two consecutive isoheds, Pi, and Pi is equal to this Pi minus 1 plus Pi by 2 as depicted here. Simply the mean. Now find the area bounded between these two isoheds. Suppose the area is area between this P1 and P2 gauge is A2. Or we can say the area between the I minus 1 contour line and I contour line is A2 or AI. AI. Now, just put this value AI and PI in the this formula and we will get the average precipitation by this expression. P average is equal to summation of PI into AI by A, where PI is the average rainfall depth between two boundary isoids and AI is the area between these two consecutive isoids. And capital A is the area of the catchment. This is considered one of the most accurate method because it captures the real spatial pattern of rainfall. It accounts for rainfall in every part of the area. Also, the orographic effects is considered through the way contours are drawn. The next method, which we will discuss in this lecture, is reciprocal distance square method. The reciprocal distance square method is popular interpolation technique, especially useful in GIS software. In this method, the rainfall at any ungauged point in the catchment is estimated from nearby gauges. Suppose in a catchment, there are 2 points x1 and x2. So the distance between these points can be calculated by simply this formula root over x1 minus x2 square plus y1 minus y2 square, where x1, x2, y1, y2 are the coordinates of these two grain gauge or these 2 points. Now, the weight of each point can be calculated by 1 by d square. It means the influence of a gauge decreases with the distance. Specifically, it's inversely proportional to the square of the distance. So closer gauges have much more weight than the distance one. And the P average, that is average precipitation, can be found by the formula summation Pi Wi, where I is equal to 1 to n divided by summation W. So these four methods we have discussed to find the average aerial precipitation. So thank you for watching this lecture on average aerial rainfall. We covered why we need aerial averages, the four main methods: arithmetic, Hessian polygon, isoidal, and reciprocal distance squared, along with their formulas, assumptions, and advantages. If you have any questions, feel free to drop them in the comment section below. I would love to hear your thoughts or any experiences you have had with these methods. Thanks again. Stay safe and see you in the next one. Take care. Jai Hind.